Hi, my name is Ben, and I'm the Chem 350 SI instructor, and today we're going to be talking about how to interpret Fisher projections and how to name molecules with chiral centers. Okay, so here we're looking at a Fisher projection, and Fisher projections are useful for indicating stereochemistry when you have more than one chirality center. So these points where the lines cross perpendicular to each other are in fact carbons, these points right here. And then everything that's attached on a horizontal line is on a wedge, which means it's coming out of the page at you. So we're kind of looking at this molecule in a kind of strange way, but we'll figure out why in just a second, because it's really helpful for looking at multiple chiralities. And I think this is probably the best way to interpret them, is if you go ahead and just make it clear to yourself that these things going horizontal are coming out at you. And then if you make these dashed lines, then we see that they are in fact going away from us. So we're kind of looking at this molecule in a little bit of a funny way, but it's really helpful when we're trying to interpret multiple chirality centers. So let's start with this first one up here. We've got a hydrogen and a chlorine and an oxygen and a carbon. So this is definitely a chirality center. You have to be careful because everything shown in a Fisher projection might not always have chirality, but in this case it does. Hydrogen is going to be our number 4, as always. And then we've got a chlorine, which beats an oxygen. It has a higher atomic number, and both of them will beat carbon. So this is going to be number 1, this will be number 2, and then this whole group down here will be number 3. And we are looking at it with our number 4 group going back, which we have to do to CRS. So 1, 2, 3. We are going in a clockwise direction, which makes this an R stereocenter. And we can do the same with the bottom here. And these numbers are, remember, these priorities are only really applicable when we're doing one chirality center. So we'll get rid of those and we'll start fresh down here. Now we're looking at another hydrogen, a carbon, another carbon, but this CH3 is you can prioritize it differently than this whole carbon group here. And chlorine is definitely different than those. So we've got another 4 different group. Carbon, here chlorine is going to be number 1. Again, because it's got a higher atomic number than all the others. Hydrogen will be number 4. And between these two, our CH3, we tie at these 2 carbons, but this CH3 has a hydrogen, another hydrogen, and another hydrogen. So we have to look a little step further out. And on this whole group right here, this carbon is attached to an oxygen, a hydrogen, and a chlorine. And we'll write the chlorine first, then the oxygen, then the hydrogen, because if this first atom beats the first atom here, and we're labeling in decreasing atomic number, so if you beat on the first group, in this case chlorine does beat hydrogen, but also the oxygen beats hydrogen, so this is a much more, it's a much higher priority group. So we'll put this, we already have 1, so this will be our number 2 group. This is our number 4, and that means this is number 3. Okay, so now we can look for R and S. In this case, we have 1, 2, 3, 1, 2, 3, and our number 4 group is back. We're looking at it in a clockwise rotation, so this is also going to be an R group, an R chirality center. So how do you name this? This is the final step. You can redraw it, but it often leads to quite a bit of confusion. So let's just look at how many carbons we have. We have 1, 2, 3. That's the only carbons we have in this whole thing. So it's 3 carbons. That means it's a propane. We also have this oxygen. So we have this OH group, which is going to take immediate priority. In this case, it's also on the 1 carbon, but you always have to give an OH group the lowest priority. So it's attached to this end carbon here, which will make the 1 carbon, because we give that OL, we say propan 1-ol, because we're giving that oxygen, it's the highest priority. We also have 2 chlorines, 1 on the 1 carbon and 1 on the 2 carbon. So 1, 2, dichloro. And we also have these chiralities that we have to mention, because it is important in the name to say which chiralities each stereocenter is. So this is pretty much our whole name, but we have to put in front of all that what the chirality is at these 2 centers. So on this 1 carbon we have an R, so 1R, comma. On the 2 carbon we also have an R, so 2R. and we put a dash because there are no spaces in IUPAC names. 1,2 dichloro propan 1-ol. And so that's it. We've named our molecule and we've gone from a Fischer projection to an IUPAC name.